So we have 0 viewers. Excellent. All right. Hopefully some. Yeah, that's fine. That's fine. I mean, they're only going to see me for a brief period. Once I share my screen, I'm gone. Okay. So, and then. So do I need to do something to? Are people automatically muted?
Yeah, when they join, they're automatically muted.
Okay. All right. Just making sure.
You can also mute them.
Okay.
Or kick them out.
All right. I'm not.
Advanced it.
All right. So let me share my screen. Well, should I start? Should I like officially start?
Well, I mean, this is for posterity, right? So
Well, I mean, you guys are here too. All right. I will start starting in 5 minutes. Okay. So I will share my screen. Okay. And that looks okay, and then that should be fine. All right. So, should I tweet a link to this thing? Oh, I have to invite people. Forgot.
Well, that doesn't matter. They can still come and watch the live stream. Whether you pull them into the Hangout or not, they can still watch.
Oh, okay. So I can still tweet a link to this. So if I tweet a link to this thing down here, they can maybe watch it?
It'll bring them straight to the screen. They'll be watching you, but they'll be like a 3-minute delay.
Yeah, that's fun. Oh, interesting. That's funny.
Live.
Yeah, I hear you. Well, should this. It's funny. Okay, and then okay.
Oh.
Pearl, right?
It used to be that our organization required to how's that before
That's a distance pass, right? Well, it's TARDIS and.
Is that the movie that the one that they showed at?
I usually don't watch terrible movie night.
So you know what I'm talking about?
You mean Bill and Ted's Bogus Journey?
No. It was Yuri Goodman.
Right, I know.
One.
Right.
One with it was called like the teleport company. It's like everybody hates the teleport company. It was a comedy, but it was just ridiculous. It was like Dumb and Dumber.
Okay.
To the nth degree, 20 years ago.
All right. Okay, well, I think we're ready to start, so I'm going to go ahead and start. We have 0 viewers, but 6 participants, so I don't know how this game works. Yeah, I don't care. I'm not vain. Okay, so I'm going to talk about a handful of things in this talk. This talk is called Miscellaneous Debris. It's an ode to actually one of the people who's participating, whatever that means. Ricardo his 1.21 gigawatts. So it's a handful of talks put together, although not quite as laser focused. So we'll talk about Docker. We'll talk about various tools, which includes Vim, Z Shell, stuff that I've written. We'll do a brief detour into DBIC class, and you guys can ask me lots of questions. We'll talk about DBIC class helpers, some of the ones that are important. We'll talk about a thing that I made called DrinkUp, which is just sort of it's just a cool program that I wrote that's got some fun features. And then lastly, I'll end with some Dogma, and we can all fight. And that will go over simplicity and asynchrony. So let's start with Docker. Okay, so Docker. This is our agenda. What is it? Let's look at a brief history. We'll look at the small stuff. So how to set up a Docker container. The big stuff, so how to run them, various miscellaneous stuff, and then I will do a live demo, so that probably won't work. Okay, so Docker. It all started with, well, that's history. So Docker is a way to group processes together. So if you've used Linux or other Unixes, you probably know about ulimit. That's a way that you can say this process has this much memory or can use this much of the CPU or whatever. But that doesn't work very well if the process ever forks, and you can't really block a process from forking. So, like, once it forks, that child process can then use the same amount of memory, and so you've used a gig of RAM twice or whatever. So your limiting doesn't work great. So this lets you group processing in that account. Also, it lets you isolate processes from other processes. So it lets you get basically a whole process table per container. So you'll see that basically when you start a container, you'll be able to do PS and see like one thing. It's a lot like bad virtualization. So it seems like a cool way to make a VM style thing, and that's okay, but the Linux system call interface is actually way bigger than x86-64. So the virtualization is actually more likely to have security flaws and stuff like that. But it'll be faster. So Docker actually makes this stuff a lot easier than it was in the past. So a brief history. So we started with chroot in 1979. You all may know of that from managing an FTP server or whatever else. Later, 20 years later, someone implemented jails for BSD, and jails are basically the exact same thing as the containers that are in Linux. I don't know how much namespacing or grouping there was in jails, but it's the same thing. And then in 2007, Google contributed some code to the Linux kernel to add the C groups, which is basically what containers are based on in Linux. So thanks, Google. A year later, LXC came out. I used LXC a little bit myself to experiment with containers in Linux, and it's pretty cool. You can do all the stuff that you can do with Docker, but it is not easy, and it was a big hassle because basically you ended up doing kind of like deb bootstrap type stuff that you would do with Debian, and it just you ended up with like a folder that had the whole other computer's root file system in it, which is fine, but it was just kind of a mess and a hassle to deal with. And then in 2013, both Docker and Let Me Containerify That For You came out. Docker is what I will be talking about, and then LMCTFY is what Google released, and it sort of felt like it was on the heels of Docker, and they were like, wait, we have this thing, but it was too late, and it kind of almost seemed like they released this thing to, I mean, I think that they probably wanted to release it sooner, or rather, they would have rather release it before Docker, but Docker forced their hand, and so they released it, and it's just, I don't know if anyone outside of Google uses it. It's kind of weird. And then more recently, there's this thing called AppC, which is a containerization standard in a tool called Rocket. That's what CoreOS is working on. It's kind of interesting because unlike Docker, where there's a central daemon on your computer, Rocket containers are run like a regular process in Linux. So they're just run underneath the current process, which is, I think it's probably a good thing, but it's different. So, and that actually was December, so it's very new. And I'll publish these slides later so you guys can click those links. Okay, so in the small, Docker is, you use Docker files to define a Docker container, or rather really a Docker image, and I'll get into the distinction of that in a minute. Well, not yet. Docker files are basically like, they're kind of like Travis files. They're basically a little YAML, or not really, they're a DSL that let you define commands to run and a couple other metadata things. And each command that you run adds a layer to these images. So images, think of an image like a class where a container is an object. So you have an image and it is the unrun version of the container. So you have an image, you run it, it becomes a container. Images are layered, so those Docker files add a layer every time you add a new statement. So you can leverage that by defining a container or an image or whatever. You define your image for, let's say, all of your Perl projects, and then all of your other Perl projects are based on that container, and so you can share that base both in, download and also on disk. It will be shared. So that's kind of cool. It's kind of like a Git type thing. There's actually a ton of options for what these layers are implemented with. Until recently, AUFS was the only option. These other ones are doable, but it's kind of like a pass-through disk with a virtual machine. It's a huge hassle to set up, and nobody's going to do it on their laptop. OverlayFS is the new one. Everyone should be using that soon. There are a handful of commands that you run on a daily basis with Docker. Docker build will turn a Docker file into an image. Docker run will run an image into a container, if you will. Stop will stop a container. It doesn't remove it, so you can resume it, but it stops it so that it's not resident in memory. RM will remove the container. RMI will remove the image. Images will list your images, and PS will show the running container. So like right now, if I run this, I can say Docker PS, and that's a little weird because it's not quite lined up right, but those are the containers that I have running all the time. And then if we do Docker images, we can see those are all the images that I have on my computer. I recently cleared them all out, but I've got a bunch of database stuff for testing, DBIC class helpers, and stuff like that. Docker is really, really helpful for out-of-the-box development. I use it for databases, like I said, all the time. In fact, with DBIC class helpers, when I make a build, I actually spin up a MySQL, a Postgres, and an Oracle database, all for testing at build time. So yeah. I have not used it a whole lot with my own code running inside of a container itself. You can do it, I just haven't. -F lets you specify a Docker file, so that probably helps, so you can run a different Docker file depending on what environment you're in or whatever. Yeah. But as usual, there's no silver bullet. You think that you could set up containers to know what's in your environment, but the fact is at some point you're going to have to build a new one to either update dependencies or something like that, and it won't just magically solve your problem. When you initially put something into a container, it doesn't just magically everything work. This is what I found out, because chances are you're using a different operating system or maybe a different version of Debian, who knows. If you don't already know, Carton is awesome and great for this kind of stuff in Perl. So I highly recommend anyone who is deploying a Perl project, check out Carton, or maybe the new thing, Carmel, which Miyagawa is hoping to replace Carton with. And then this link at the bottom just kind of talks about all those different storage layers or layering options. Okay, in the large, whoops. sorry. In the large, you are going to want a Docker registry. So those layers that I talked about, those only apply, or they only help when updating a server if you have a registry. So you can push images from your laptop to your server, but it's going to push the whole image every time. Whereas if you use the layering and you have a registry, you can push just the changes to the registry, and then on the server pull just the changed layer. So instead of it being a 300 megabyte image, it's going to be maybe a 5 megabyte application. This is how we push it at the company that I work at today. You say Docker push the name of your application, and then the domain of the registry that you're having, and then the port that it runs on. You probably shouldn't run it on port 5000 like we did. I was just under the gun when I set it up. Then on the server, you're going to pull the exact same thing, the actual host that would be running the container. And then finally, you're going to need some kind of shell script that you're going to have to run to start the container. Basically, whenever you have any state that's persisted or ports that are opened, that's another flag that gets passed to Docker run. And the fact is, every serious application has state. It would be awesome if we didn't have to, but you just need it. So, and then again, or just to reiterate, all those, the state that you have to have, the ports, all that stuff, those are the things that are going to break. So you can make a container and everything be perfect, but if the stuff that is the state changes from underneath the container, that could that'll break it in the future when you need it to work. Basically, what I'm saying is you can test your container in isolation and everything work, and it still not work on your server because it's more than just this static thing. Okay, here's just some random stuff that I use with Docker and really enjoy. Pause and unpause, it kind of does like sig stop and sig cont, except the application can't trap it. So I use this to like pause certain services that I have running all the time on my laptop, and that way basically the container is still running, but it's not actually actively polling or whatever it needs to do to run. Sysdig, I will show you this because it's awesome. Sysdig is kind of like strace on steroids. It's somewhere between strace and dtrace, where dtrace is the most powerful but the hardest to use, and strace is the least powerful but the easiest to use. Linking containers, let's see if I have a bullet point. Yeah, so linking containers it's complex, but arguably it's the best way to compose together your containers. So you can use this to spin up a database container and an application container, not give anyone access to the database except for the application container. So you could do this to basically, it's kind of like a ghetto firewall, but the nice thing about it is you do this and the kernel is not even letting the database listen on all interfaces. It doesn't even have a public interface to listen to. So it's just, you can make things more secure that way, and again, composable. I think you can use it for volumes. I've only used it for network access. The neat thing about linking containers is that you can use it to basically mock network interfaces. So I've used it to, I have like an Apache container and then like 5 other containers that it talks to for like an application you might have heard of, a sync thing. It has a little web interface, and I actually, in testing, proxy to a little Plack app just to make sure that the proxying is working. And that's just a different way. I just run it differently to set up that linking. Testing is, it can be difficult. Like, just because you made a container doesn't mean that suddenly testing is easy. If you already have continuous integration, testing is going to be great. In fact, I suspect that it'll be even better because you can push your pre-built binary instead of maybe parts of your application like you might now. That linking that I talked to you about before, I have a link to my my test that's doing that. Again, it's awesome. And I've already said that a million times. So people are actually working on this whole, like, the volumes in Docker are the moving parts, and they're not as magic and nice as everything else in Docker. So there's a thing called PowerStrip, which is an API to make extensions to Docker, and then there's a thing called Flocker, which is basically volumes, but like with Docker. So basically, you can have layers the same way that Docker has layers. You can move volumes from one host to another really easily. It's really, really cool, but it requires you to run ZFS, so it's like it's kind of a big deal. You can't just like install it like you can with Docker. Oh, and then let's see if I can. The internet is slow, so you should use Squid. At my current work, we have pretty slow internet, and so I set up, this little GitHub link will show you. You can spin up Squid in a Docker container and then run a single IP tables command, and it'll make all containers go through that Squid for port 80, which means if you're spinning up new containers, it can be way, way faster because you're not going to the internet to download your Debian files every time. Okay, so demos. Let me show you guys a Docker file real quick. So I run offline IMAP in a Docker file, or in Docker, because offline IMAP crashes for me all the time. So let me show you. Let me show you some of the stuff that I do with this. So basically, I base my container on Fusion base image. That's basically a thing that makes running containers with multiple processes in it easier. It has some other stuff, but it doesn't matter. I run this init that comes with that thing as the default command. It has these exposed volumes. So this is where my mail goes. This is where the index for the mail goes. This is where the logs go, and then this is where the configuration goes. I expose this port, but I never use it. That's for interacting with Monit, which I use because offline IMAP leaks like a sieve. I add these files to the container just because that's what I need for everything to work. And then I run this one giant command to set up all the files, and this is everything. So I run that as a single command because that way I won't get a separate layer for each one. I just don't want to have, what is that, 1, 2, 3. I don't want 7 layers for each of these things when like 2 of these are just creating symlinks, etc. But the neat thing about this is basically, I'll show you the services directory. So I have a, these are services? Yeah. So I have 3 services. One called offline IMAP, which just runs my IMAP synchronization. One, which is Monit, which kills it if it reaches more than a gigabyte of memory. And then another one called Cerberus, which is just a little Perl script that I have that it kills the process if it doesn't log for 10 minutes, because sometimes offline IMAP just hangs, which is just, it's the worst. It's so annoying. Somebody want to rewrite it in Perl so I can help? Anyway, so all that stuff runs in my Docker container. In fact, if I could show you, it should be running right now. I'm going to make this smaller. You might not be able to read it, but you can still see it. I'm going to find it. Use Chrome. So here we go. This is my Docker container that's running offline IMAP. So it has its own little init script. It's running syslog and cron. But then as the user, it's running my little Cerberus, offline IMAP, and Monit. And so you can see from the host, we can see everything. We can see it perfectly. But if I run docker exec offline IMAP bash inside the container, if I run ps, that's all the processes that you can see from inside the container. It doesn't get to see outside. And in fact, it thinks that this init script is PID1. So that's pretty cool, right? All right, so do you know how fast the internet here is? Anybody know? Not great. Okay, I'm not going to build this right now. It is really fast if you have fast internet. If you don't, it will take a while. I'll show you what I do to run it, just so that you can see what the volumes and stuff look like. this is my little script that I have to run Docker, or to run offline IMAP. I stop it, I remove it, I make sure that I pull it, because Docker, the company, actually runs a service to build containers on demand when you push to GitHub, which I use. It's handy. So when I run this, I daemonize it. I set the name to the offline IMAP so I can stop it later. I make a volume of my netrc to pass my password, a volume of my mail to pass my mail, the logs and the index like I talked about, and then I restart it if it crashes automatically. And then here's the name of the image. So that's how I run it. Generally speaking, you don't need that many volumes, but such is life. Okay, sysdig. So I talked to you guys about sysdig. I'm going to quickly run sysdig without any arguments, and you will see a million things scroll by. This thing, like I said, it's like strace, but it's everything on your computer. So I'm just going to Control-C that. You can see it's taking a while to go away. So let me switch screen. There we go. So that's like everything that was happening on my computer. Now, if I say container.name equals offline IMAP, oh, wrong. This will show you all of the system calls that are running inside the container. Here's a neat thing you can do. We can say I want to run the chisel spectrogram, and this will actually show the speed of all the system calls running inside the container. So you guys see that slow system call on the far right? Anybody have a guess as to what system call that would be? People in the channel can guess too. Nobody? Okay. Well, I'll show you, but I'm pretty sure it's a timeout. It's a poll that has a timeout. So now what we can do is we can say and evt.latency.s is greater than 1, and we're going to quote that because otherwise it'll redirect. And we'll see, without the spectrogram, the actual exact, yeah, so that's a poll. And poll, basically, in Linux, you tell it to poll, and eventually it'll come back. So here, we could do this to see if, like, for instance, we had slow writes or something like that, and then select. It's kind of another kind of poll. So anyway, yeah, that's pretty cool, huh? Okay. Oh, and then I have a little thing that I use to tail the offline IMAP logs. I don't really know why I said that I should show people this. Literally, it's just tail with a bunch of files after it, but that's kind of cool, right? Okay, so that's the end of that. Anybody have any questions about sysdig, or rather, offline IMAP or sysdig? I mean, I meant to say containers, but either way. Nobody? Okay. I will move on. Okay, so let's look at tools. All right, so I'm going to talk about Vim, Z-Shell, Awesome, which is my window manager, which is what's letting me do this kind of stuff, and wrappers, and some remote stuff that I've written. So I'm just going to talk about a little bit of Vim stuff, but if you use Vim, you need to know your text objects. Some main ones are W, IW, AW, IP, ibrace, iparen, whatever. Anybody in here a Vim user and not know those things? You know all of them or not all of them? Okay, well, just so like IW lets you delete inside a word, not including spaces. AW lets you delete the word and the spaces surrounding it. IP lets you delete a paragraph. Any kind of brace lets you delete the thing inside the braces, not including it. Like these kind of things, they're so awesome and they're so convenient. And you can use dot to repeat it on another word or whatever. Awesome. And then there's actually plugins that add new text objects. So how often do you want to highlight a whole file and you type GG capital V capital G? Yeah, exactly. % plus Y or whatever to copy the whole thing into your buffer. With this, you could type %+YIE. So that's pretty cool. Or to delete the file, DIE, which is fun. So there's some really nice plugins for these kind of things, which are super handy. If you don't know what the quick fix is, you should learn about it. I use unimpaired to use it more easily. It adds some hotkeys in normal mode to go forward and backwards in the quick fix. And then fugitive is a thing that I use it with, and I'll talk about that in a minute. GV is a random thing that I find myself using constantly that reselects the previously selected region. So if you selected something and replaced it and press GV, it will highlight the replacement. Okay, so here's some plugins that everyone should be using. Repeat makes the dot command work with more things, like plugins. These are almost all Tim Pope plugins, by the way. Surround lets you manipulate parens, braces, etc., replace them with other kind of markers or whatever, or also just remove them. Fugitive is Git integration, and it's awesome. That thing that I was mentioning before, you can go into a dot file or some directory and say ggrep, and then I'll say fREW, and this puts all of the fREWs in my in the repo in my quick fix, and now I can just jump through them with the quick fix stuff that I already use. So it's super handy, and then all the stuff. So very cool. It does more than that, but that's something I use all the time. Commentary for toggling comments. Ultisnips, it actually lets, I almost never use this, but if I am editing a markdown file, I can type this to start a new blog post, which is just kind of neat. Neocomplete is really cool because it is on all the time. So like if I wanted to look at a file, I can just like type, and look, it's already auto-completing all of the files in the current directory, and I didn't have to configure it or anything. I just turned it on, so super handy. Control P is one of those hot new things that lets you open a file somewhere. So if you don't care about that kind of thing, that's fine. Another option is dispatch, which I use for more structured things. So like in my in my project that I use at work, I can say result to edit a DBIC class result class. So like I could say setup here, or I'll just say config. So like I can do that, and then if I do capital A for alternate, it will edit the result set. So that's pretty cool. We've also got Syntactic. I think I typoed that somewhere there. That basically turns on error checking in files that are compiled automatically. It's pretty cool. It's a little slow on Perl because by default it runs Perl, not Perl. It does the static checking based on Perl best practices. Matchmaker basically lets you put your keyword, your cursor over a keyword, and it'll highlight that same word elsewhere. So it's good for if you typoed variables. Unimpaired is, I mentioned it briefly before, it gives you a lot of little tools to traverse through file listings. So you can use it for the quick fix list. You can use it to just iterate over files based on lexicographic ordering or whatever. Super handy. Like if you wanted to edit all the results, you could just use ~F to go forward in the directory tree. Those text objects that I mentioned before, those are the names of those. Visual star search is a random thing where you can highlight something and press star, and it'll search forward in the file for that thing that you highlighted. Okay, Z shell. I have a cool prompt. I'm proud of it. It has the host name, because I always know what user I am. It's the same thing everywhere. This awesome skull, because one day we all will die. This is my history, so like I can say bang 25392, and that, oh whoops, 1, because 2 has not yet happened, and that's the vi that I ran here. So that's a really weird random thing that I can do, but some other stuff that's neat too. The directory that I'm in, the Git branch that I'm in, there will also be some stuff that's not shown here if the Git branch is dirty or the previous command ended non-zero. So like if I say Perl and then Control-C, that was the exit code because it was non-zero. These are some options that I use with Z Shell that if you use Z Shell, you should too. Auto CD will change to a directory if you just type the directory name. Auto pushd will put it in your pushd list. So like, who thinks doing CD minus is cool? Yeah, that's pretty cool. You can toggle through directories. But doing popd is 10 times cooler because you can go to the previous directory that you were in before because there's a stack of directories. That's what this thing is here. That's what auto pushd does in Z Shell, and it's awesome. No case glob basically makes it so that globs ignore case. There's all this random stuff to deal with duplicates in both pushd and your history. Basically, I have it so that if there's a duplicate in my history, it gets pruned. Same with pushd. Append history, everyone who cares about anything has this on. Otherwise, every time you start a new shell, your history gets blown away. Extended history logs the timestamp of every single command you run. So if I look at my shell history, the first command I ran on this laptop was code, and that's just a Unix datetime. So let's see. See what duck says. Yeah, so that was June 14, 2012. This laptop is not that old, but I copy my history around because I'm a weirdo. So that's really nice. Also, if you search through history, it won't find any duplicates. And then finally, oh, not finally. If I put a space before a command, it won't go into my history file, so that's nice if I'm like typing a password or something weird like that. Share history is awesome. So like if I type hello world and start a new shell, well, that's not exciting. So let's type hello station. And here, I'm going to just type ls so that it reloads its history. And then look, now the history is in this other shell too. Super handy. Okay, so that's all the options that you should use with Z Shell, or at least those are the ones that I think are the most exciting. Global aliases are really cool. Basically, you pass that -g flag to alias, and it'll make an alias that can be run in the second half of a command. So like I can do lsg d to find all files with a d in them instead of typing ls pipe rep d. So it's just one of those things. I can also pipe to L for less. Why that didn't work? Oh, because it's a follow. Well, that's weird. I can also type capital UP for upstream, which is a really nice thing to use in Git, but it's really a hassle to type, so I made a little alias for that. PT for pass through because I don't want to type or remember 2 greater than &1. And then PTV to pass through to Vim so that I can copy the output of something. Okay, so I also use this thing called Awesome, which is a window manager. It's what lets me do this stuff here. It's pretty cool. It's based on, or at least I have it configured the way Xmonad is configured by default. The problem is Xmonad is Haskell, and Haskell is a huge hassle to get right. It has terrible error messages. It hated me when I used it. Awesome is configured with Lua, and everything is easy. I also, you can't see this on, well, I can't see this. I can see it if I look at the screen. This stuff up here, this is the weather in 3 different places. The cool thing about this is that, well, cool, I don't know if this is cool, but solving problems is cool. Awesome is not asynchronous or multi-threaded. So when this weather stuff used to check for weather and I didn't have Wi-Fi or whatever, my whole interface would block and I wouldn't be able to like change windows or anything like that. It was terrible. So what I did was I wrote a little Perl script that actually runs in a container now that asynchronously checks the weather and then also just looks at the files on the hard drive. So that's a cool thing to have solved that problem, right? But it'd be nice to not have. Okay, and then I made this thing. This is RJBS's fault. He always talks with emoji, and I was annoyed that I'd have to like go to the internet and like Google something to be like, oh, skull, Unicode, or something like that to, and end up on this terrible website. So I made this thing that I can press Windows key U, and you can see at the top it lists it actually lists every single Unicode character. So I could say cat face or whatever, and copy that, and then I can just paste this in here. Like, that's pretty cool, right? So I actually split it up into 4 scripts. I'm not going to show you the code for that now, but again, because of RJBS, he tweeted a picture of his history of his emoji. So last week I made this thing that has my Unicode history in it, and so it shows all the characters that I used. It's pretty recent, so I haven't done a whole lot with it. But the neat thing is now you'll notice that these it's in the wrong order. I just realized that. But my history is prefixed, so now I can just do cat face again. So that's kind of neat. Okay, so wrappers. If you guys use Git very much on the command line, you probably use the staging area, and if you use the staging area and stage part of a file, like that's kind of a hassle to do, especially if you like edited a patch to stage just like part of a line that changed or something like that. And then you accidentally do git commit -am, and you committed everything, and you lost it. So I made this little wrapper around Git that will say, oh, hey, you already had something staged. Do you really want to do that? Because it's the worst when that happens. So this actually asks you if you already had something staged. Very, very handy. It also makes pull always do FF only, and if I check out a branch in a certain format, it doesn't track it. So that's super awesome. Also tar. Did you guys know that for tar, you're not supposed to have the dash? Probably. Did you know that you don't need to pass the format that you're extracting, and you haven't needed to for years? I have a helper that will, oh shoot, I opened Firefox. That's I have another wrapper that will, that's not going great. Yeah, that it'll tell you you don't need to pass these things. So yeah, that's just one of those things, me trying to be better. Okay, if you work with human beings, they will give you a zip file that has the DS store from a Mac user, the thumbs.db from a Windows user, or someone will give you a tar file or a zip file that does not have a folder in it, and it'll just explode into the directory you're extracting. I have this thing called replace unzip, which is just totally implemented in Perl, and it completely replaces zip, works with archive zip, and automatically filters out those dumb files, and if there's no root directory, adds a root directory, and it's awesome because you can't really do that very easily with the console version of unzip. So this is just solving problems, you guys. It's great. I have this little thing called corn that it's a bunch of feeds that I follow that I need to filter. So it's kind of like Yahoo Pipes but written in Perl because Yahoo Pipes is eventually going to go away. So like, for instance, I follow this guy's weird things, but I don't want to see the videos or audio. I am a cheapskate, so I read Linux Weekly News, but I don't want to see the paid posts till they're free. And then I follow cpan testers for my user, but I don't care about certain things, so I filter them out. So yeah, it's just one of those things that just make your life easier. I'm using Docker to migrate all the stuff on my Linode to OVH because Linode keeps getting yeah. No, I have it running on Linode. Yeah. So if I go to a foolish manifesto, actually, if I go to feeds.afoolishmanifesto, manifesto.com/LWN. That actually proxies to Linux Weekly News and filters out the stuff that I don't want to see. Or if I go to, let's do rising tensions, and I'll see weird stuff. This took out all the videos because I don't want to see the videos. So yeah, that's how I use it. That answer your question? So yeah, Linode is bad at getting DOS'd. So if you use this thing OVH, you will get contracts saying that you will not get DOS'd with their service because they'll handle it for you. And so I'm using Docker to migrate all the stuff that's running on my Linode into OVH, and that's exciting. And then Gitolite, if you don't use GitHub for something because it's internal to your work or it just needs to be private for some reason, Gitolite is a really nice, lightweight Git user or whatever management system. It's all written with Perl and SSH, and I think it's beautiful, and so does Randall Schwartz, so you should use it. Okay, that's all for tools. Any other questions about tools? Oh yeah, without a doubt. Dude, so this uses a thing called XML feed, or rather feed pipe, and feed pipe lets you mutate feeds really, really easily. So I mean, like, all I'm using here is just these like little shortcuts that I made to filter out certain posts, but you could also use it to mutate the content really easily. Or you could use it to like look at the link of a feed and then proxy through to the actual like webcomic or whatever. So, make sense? Yeah, we all read those comics. Okay, any other questions? Nope. Okay, so Gitolite, let me show you my personal. So here's a neat thing about Gitolite. If I say SSH Gitolite at foolishmanifesto.com and info. Whoops. Oh, that's weird. Did I type it wrong? Oh, I gotta say sorry. So if I do that, oh man. Well, I have a shortcut, so I just type SSHAGM. This lists all the repos that I have access to on my server. I can also do the same thing for my work server. And see all the various repos that has access to. But so that's already really cool because a user sets up their, or I add a user and I just say, hey, SSH this thing, and it'll list the repos you have access to. So we can say, did it work? Did it show their the repos that we want them to have? The actual configuration is really handy. Let me show you. So if I look at my keydir, that's just my public keys for each computer. Nothing surprising there. And then if I look at this conf, I have a handful of pre-made repositories, and then also if I push to a repository of u/fru/ and then some word character listing, it'll automatically create the repository and share it with everyone. So I mean, that's basically it. You can be more fine-grained, like you can block certain users from pushing to certain branches, but it's super nice. I really like it. Like you could, like here, we could say foo, and only allow, whoops, foo, and this would only let people push to the branch called foo, for example. So yeah, that's Gitolite. I think it's awesome. Other questions? All right. Okay. So let's talk about DBIC class really quick. This will be, whoops. This will be the fastest DBIC class ever. I'm kind of tired of talking about DBIC class. I've done a lot of the talks. If this is not enough, you can look at more on YouTube. But I will answer questions because nothing beats asking questions live. Okay, so here are some things that people get confused about DBIC class all the time. schema. A schema is a set of tables. That's it. If you think that it could be more, you already know more than you need to know for me to talk to you about this. A result source is basically a table. It could be more, but for people who are noobs, it's a table. There's a result set, which represents a query. A lot of people get confused about this and think that the result set could be, for example, all of the rows in memory, but the result set has not hit the database yet. It just represents the query itself. The result is basically just a row. So yeah, those are the major parts of DBIX class. You have to understand this, especially the distinction between a result set and a result. If you accidentally pretend one is the other, it will not work. Also, relationship types, this is a common point of confusion. Has many means that some other row has my ID in one of their columns, or one or more of their columns. That's all has many means. It doesn't actually mean that there's multiples, and in fact, you could somehow guarantee that there's only one, and DBIX class wouldn't care. It just cares about where the ID is. Belongs to is the other side. Belongs to means I have an ID to some other row. Now, you could have an ID to some other row and set it up wrong so that that points to multiple rows, and DBIX class will just give you a warning and continue to work. So you can lie to it. You shouldn't, but you can, and that's because who knows what you did with your MySQL database. Has one is it's like has many, but you're ensuring that the other side there's only one of them. I very rarely used anything other than has many or belongs to, by the way. Might have is even weirder. Basically, you say there could be 0, there could be 1. And then finally, there's many to many, which is not really a relationship, but it adds a few helper, or really, I think just one helper method to directly traverse a link table. So basically, you would have a table, a link table between that table and then another table. So think users, users tags, and then tags, or permissions might be a better way to put it, but whatever. Okay, that's it. Anybody have any questions about DBIX class? All right, good. Okay, DBIX class helpers. So, oh, come on, dude. It says that I can't, but I can. All right, so DBIX class helpers is a bunch of little components that I made for DBIX class. I can't talk about all of them. There's probably 30 at this point. I just looked today, and there's like something like 400 commits to the repo, and each commit is a feature about. So it's gotten big. There may be a lot more of them. So take a look at the actual page where you can get a listing, and that might be more helpful to you. All right. So this is actually a pretty new helper that I added in just the past couple weeks. I found that I needed to verify certain things about results and result sets. Most importantly, recently, I found out that if you don't set C3 on your result set, terrible, terrible things happen. So first I made C3, then I made parent so you can ensure that your result set and your result have the base class that you want it to have. Correlate relationship, basically this allows you to have another query pretend to be a column on your result set. So for example, in this example, you can correlate the plays of all the tracks on a CD as a column. So you can sort and search by CDs based on the counts of all their tracks. So I mean that's for track plays. That's pretty cool. I'll talk about this more in another slide, but this is really powerful stuff, and I found that, or someone told me on the internet that if you Google fREW result set, you'll find an article I wrote about this. Date methods is a pretty recent helper, I think maybe less than a year old. It lets you do date math generically in all databases. So very handy, can make moderately more readable code, and again, it works everywhere. So pretty cool. It automatically converts date time objects for your database, and it can extract the date parts from columns, and you can even search on them. It's pretty cool. And you can add dates with date parts, so you can add a year to a date in the database. It doesn't do subtraction yet, and that's because every single database does that differently, and I have yet to find a good excuse for that. Okay, ignore want array. I don't know how many of you have run into this bug right here, where you did a search and accidentally pulled the whole database into your function. This fixes that bug. Use it. Search or, DBIC class search is fundamentally a way to compose queries together with and. I need or sometimes, so search or lets you do that. It's kind of like a ghetto union because it can't handle joining in other tables. More caveats are actually listed in the man page for it. Set operations lets you use actual union, and I cannot believe that this isn't core. This gives you all the set operations that you need with DBIC class. DBIC class Candy, this is great for slides. Basically, it means you don't have to write __ package _ arrow before every single thing in your results. So this is what a package using Candy looks like. I recommend everyone use it. It's great. It should never cause you a problem, and it has never caused me a problem. And all the following slides assume it because I have to fit stuff on slides. On-column change is sort of like a trigger outside of your database. It will automatically wrap certain column changes in a function. So like you change a column, and we automatically run this column before it hits the database. I wrote this at work for a MRP system, basically. It's weird, but it's super handy. Proxy result set method and proxy result set update. I talked about this before. Basically, you can use correlate to add a related count and then proxy that result set method. The really powerful thing about this is if you don't initially use with friend count in your result set, it will do an n+1 and pull in that friend count for each result that you're iterating over or whatever. If you do use it, the methods will just keep working, and it's just a nice user-friendly way to access your data. And if you do fetch it and didn't pull it in, it caches that. So if you call the method twice, it'll only access the database once. I'm considering making the fetch on demand warn because it's an n+1. Maybe it'll warn unless a certain environment variable is set. I don't know, but we'll see. Okay, does anybody have any questions about those helpers, other helpers, or maybe deployment handler? No? Okay. All right, so let's talk about drink up. So I made drink up a while ago. I want to say 4 years ago now. I'm not totally sure. But it's got some cool features that are worth talking about. Recently, I was interviewing for new jobs, and someone asked me about some cool stuff that I'd done, and thankfully, one of the things that I made was drink up, and it's open source, so it's easy to talk about. I can even show the code. These things that I think are cool about drink up are in no particular order, and feel free to zone out for this slide if you don't care about cool things, or these slides if you don't care about cool things. Okay, so this is actually not as exciting now as it was when I first made drink up, but it's got these nice URLs that are sort of meaningful. So like if you just do drinks / you can see all the drinks. If you do drinks / data /1, you can see the drink with an ID of 1. You can say drinks / find by name and pass mojito and see a drink with the name mojito. You can say search by name, and it'll translate this star into a percent and find anything that ends in T. You can even say I want to find drinks with some ingredients and pass an ingredient ID listing or whatever. Kind of nice URLs. Again, not that neat these days. The web backend is really cool. So I made this thing with WebSimple. So WebSimple basically, oh, I need to do this raw because GitHub ruined everything here. So WebSimple is basically just a tiny dispatcher. So I say drinks slash dot dot dot, and that lets me say, well, under dot dot dot, I can do data slash star. I can also do find by name. I can also do search by name, etc. Same thing, same kind of thing with ingredients. So this is just, it's sort of nice. The really cool thing is that the meat of these things, the resources, are web machine. And so, like, let's look at the drinks result set web machine. All we do is we give it a little renderer. We give it a base class, which is just web machine resource, which Stephen Little ported from Erlang, and then a couple roles, and I'll show you what those look like in a second. So, like, for example, let's look at the set role. So if we look at this set, this basically lets you say we have to have a JSON encoder, we have to have an item renderer, we go to this certain URL. Once we create a thing, we only allow gets and heads, unless writable's on, in which case we allow post. Basically, this is a lot of skeleton code that is handled by this role. And so now if we look at drinks, we see almost nothing. And if we look at ingredients, we see about the same thing. Very nice stuff. Tim Bunce made a thing called Web API : DBIC. It's based on this code. His is way better than this, I promise, because it's Tim Bunce. But I'm proud to have inspired something that he made. So that's cool thing beta. Cool thing gamma. Ingredients are all automatically interchangeable. So I used MatPath to define ingredients in a tree structure. So basically you can say, this drink calls for vodka, and then you can put Grey Goose on your shelf and say Grey Goose is a vodka, and the queries will all automatically handle finding ingredients of that is a relationship. So that's really cool. Unfortunately, taxonomies are terrible. So, like, do you really want to use good vodka for just any drink that calls for vodka? Or what if you have scotch and you have a drink that calls for whiskey? That doesn't really make sense to use scotch in just any drink that calls for whiskey. So although I'm proud of this feature, I don't think it actually makes sense because taxonomies are terrible. Okay, so this is the coolest thing about DrinkUp. The searching is set-based. So you can say, I have these ingredients that must be in the drink that I'm about to make. I think I got it backwards. Every time I talk about this, I get more confused. Basically, excuse me. Let me show the methods that use it first. So you can say, I want to find all the ingredients that this user has on hand, except for one. So, like, the idea is, if I go to the store, if I buy one ingredient, what drinks can I make? Or I can say, what drinks can I make if I don't buy anything? Or I can even give it a range and say, I want to buy, let's see if my doc is good here. Yeah, if I want to buy anywhere between 1 and 3 ingredients, what drinks can I make? So this is done with some crazy, where are we? Some crazy SQL that is part handwritten, part generated by DBIC. So first I join in all these ingredients in query 1, and then I have another query that are the ingredients that have to be made for the drink. And then I extract the SQL that DBIC generated, and I pass it to this dual query thing. It's been a long time since I wrote this, and I don't remember all the details, but there's a lot of tests for it, so I'm sure it works. But it's crazy and awesome that you can do this, and I just want to show that you could all do this with the crazy stuff that you need to do to be able to leverage the speed of your database that you don't want to use in your application. I actually benchmarked this with SQLite, and it was surprisingly fast with high counts of ingredients and drinks. Yeah, so this is basically what drinks can be made from ingredients in a given result set, plus a range of other ingredients. So, yeah, like I talked about. Okay, so that's all the cool things about DrinkUp. Any questions about that? I don't think. Well, so I've considered. So like this stuff obviously is pure DBIC, and all the other stuff that interfaces with it is pure DBIC. The only stuff that's not is this weird little query here, and because it's so isolated, I don't have a problem with it. I would consider it now because nowadays we have arbitrary join specifications, and we didn't have that when I wrote this. But yeah. So, anything else? All right. Let's talk about Dogma. Okay. Okay. So, I'm going to talk about simplicity and async. These things are strangely linked in my mind. I don't know why. Yeah. So, DBIC class is great. We all love DBIC class. Catalyst is great. XJS is great. Or it's better than writing UI code anyway. But sometimes all of them can be overkill, or at least each of them can be overkill. I have a project at work that runs not one query, but 2 queries. DBIC class is way too much work to write 2 queries that touch 6 tables. I shouldn't need to make a schema. I shouldn't need to instantiate a schema. I should just use DBI, or maybe a DBIX connector, connect to the database, and run the queries. It's fine. If your project only has 5 API endpoints, 5 HTTP endpoints, I love Catalyst, you guys, but it's overkill for a project with 5 endpoints. It's too much. Same goes for UI. If you've got a single page UI, and I don't mean single as in the URL doesn't change, but it literally has like one button and a search, you don't want to use XJS. It's crazy. Big frameworks can make you feel like you're getting work done, but really all it is ceremony. So you think you're getting work done, but you've just defined a whole bunch of stuff around doing no work, or at least not yet doing work. All you've done is define the structure around which you're doing things. At some point that's worthwhile, but there is a point at which it's a waste of time. Don't use big frameworks for every single thing. This is my dogma. Simplicity is hard to define. It's hard to know what is simple and what's not, and what should be simple. A couple examples I have, these are both in-house examples. Proof is a little certificate authority that we wrote. It's a single web simple application. It has probably 5 endpoints. It's basically what inspired this talk. It has 5 endpoints, 2 of which are autocompleters, and 2 methods that talk to databases. One of which talks to SQL Server, and another one talks to MySQL. So even making a schema would be super silly because I'd end up having to make 2. LNM is a project that we have that was originally based on Raspberry Pi, and being Raspberry Pi, we're constrained both in memory and CPU and all that stuff, so it would have been way overkill to implement that with Catalyst and DBIC class and even a database. There's no database on this thing because it's so simple that we just store everything in memory. It's great. When it comes to simplicity, microservices can help. You can use the, I'll talk about that in a second. You can use the right tool for the job. You can use something like WebSimple or whatever for just a small part of your application, and then use Catalyst for the stuff that needs user authentication or whatever. If you're in a situation like we were with LinksNet Messenger where RAM is at a premium and you can't just add new RAM to the machine, you can probably use forking to preload your whole application and then fork off each of the specific parts of the app so that the Perl stuff is all shared in memory. Obviously that assumes you're running on Linux, but you're all smart people, so. Again, use the right tool for the job. Vanilla DBI is fine, especially like with DBIX connector, which will automatically reconnect if you lose connection. Small web frameworks, I love them. They're fine, and microservices can be of benefit. Use what makes sense. Okay, and then I'm going to take a little detour into asynchrony. I posit that async is actually simpler than polling. I can't know this because, again, how do you define simplicity? And what crazy person would say that asynchronous code is simpler? It's bonkers. but I'm saying it. It can be more complex, but you can hide some of that complexity with OO. So, for example, in that project that I was talking about, LinksNet Messenger, we have a periodic task where we check in with a mothership of a server. So that involves a timer that runs every 5 minutes, and then after the timer finishes its task, or when the timer starts its task, it does an HTTP request, and then of course there are callbacks for both passing and failing on that. So you could end up with something really gross. But because of OO, I just made a single check-in class that has all that stuff in nice little methods. Excuse me, I'm going to take a sip of water. Asynchrony requires a lot of mental reconfiguration. This can be really painful because you've made a lot of assumptions for a long time, but it turns out that your assumptions were wrong. The real world is asynchronous, and needing to think about timeouts is important, because if you don't have timeouts in your synchronous code, it could just sit there forever. In fact, if you do an LWP request and DNS times out, guess what? It'll never come back, even on Linux. That's just how it works, because DNS is synchronous on every operating system that I know of. Okay, so here I'm going to talk about async versus synchronous a little bit. So if you've got synchronous code and you've got some kind of message queue, you might use this kind of pattern. This is what we do. You've got a writer. You write what you are doing or wanting to happen into a database table, and then you've got a while one with a sleep in it, and it's just pulling stuff out of that database. All right, a lot of problems. First off, you've got a sleep. So that's a whole second out of however much time you're actually processing stuff that you're doing nothing. You could have gotten something a whole second ago and been wasting that time on your server, which you're paying electricity for and maybe actual bills on if it's AWS, who knows. You've also got write contention because you're using a database. If you write a lot of stuff to a database, at some point you're going to run into problems. That's just the nature of things. There's another problem here, but I won't talk about it yet. And then with asynchrony, you've got this other pattern. You've got a writer, a message queue, and a reader. And the reader just does nothing while the message queue hasn't sent it anything yet. Basically, it's idle because nothing is coming in from the message queue. You don't have a sleep anymore, so you're not even going around a while loop to check for a thing periodically. So when nothing is happening, you're burning no CPU. You're using no energy, you're doing nothing. But when stuff is coming in, you get it immediately and handle it immediately. And also, because it's a message queue, chances are your write contention is not going to be a problem, just because that's what message queues are for. Okay, so a thing that can simplify your async code is a thing called a future. Another name for them is promises. There are subtle differences, but it doesn't matter for us. So here's callbacks. This can get gross, hairy, hard to understand. You end up with this thing called callback soup. Got a little pyramid going to the right. It's frustrating. With a future, you end up with something more like this. You do your request, and you say, then do this asynchronous thing. Then when that comes back, do this other asynchronous thing, etc. Much easier to read, goes left to right, has some nice semantics when it comes to error handling that callbacks don't have. So that's great. Futures are good. But callbacks are the most basic form of asynchrony, and they are going to be around forever. Think of callbacks as the procedural code of asynchrony. So when you're writing code, you can't, well, you could, but we don't, write everything purely functional. Sometimes you got to set a variable, and then you got to call a method on the variable, or whatever. That's procedural code. Callbacks are the same way. Not everything can be factored into some kind of nice little asynchronous primitive. Certainly not futures. So everything else is an abstraction of callbacks. So futures represent a single action coming from a single direction that will only happen one time. So an HTTP request is a good example. You do an HTTP request, and that future will be resolved once, and it only gets information from the guy that you started the future, unless you cancel it, but that's about all you can do. You have to store a future somewhere. So this is one of those things that once you see futures, you think, this is gross. Why do I have to store it? But when you store it, you will find that there are cool things that are possible. So let me just back up. In our LinksNet Messenger thing, LNM, we store all the futures in a hash, and we actually have an HTTP endpoint that you can say, hey, what are the outstanding futures? And it'll list them all. You can say how long have these futures been outstanding. You know for each future how long it's been waiting. So it's pretty awesome. There's other abstractions that don't really exist in Perl, but there's a really cool article called General Theory of Reactivity, and it talks about a lot of these things. You've got, well, all this stuff. I can't even start to go over all this stuff. If you care about asynchrony, you should read this article. Very, very cool stuff. And again, I'll post slides later. But yeah, it's a very, very good article. Okay, and that's all I've got about async and futures. Anybody have any questions or want to throw a tomato at me for disagreeing with you? All right, that's it. That's all of the stuff that I have. I'm going to see if anyone said anything in this chat room over here. If I can get it over. Doesn't make sense. I'm not going to comment on that right now. But yeah, so that's it. I go back to camera. Well, I don't know. This is me. You? Oh, whoops. Well, it doesn't really matter. It doesn't work. It doesn't matter. Okay, well, that's the whole thing. I hope you guys enjoyed this. I am sorry that I couldn't see more of you in real life, but such is life. And if any of you are in LA soon, I will be there in 3 or 4 weeks. So have a good night. Okay, bye.